2016. Tonight we have a special surprise for you all. This is a man who has been, our next speaker is a man who's been involved with the free energy alternative technology field for actually longer than I've been alive. So he has a vast array of knowledge. He has 30 years of experience in research and aviation, 40 years plus of work in the alternative energy field. He started many, many years ago with the Bedini switch and ran from there. He told me that, he said he built one of every single thing that ever came down the pipe. And if he really liked it, he built two to see if he could make it better. I'd like you all to give Norm Wootan a warm welcome.
Thank you. Thank you. Thank you. Okay, first thing we'll do is sands his hat and hang it over here on John Maluski's water magnetizer. You look at that slide up there, that's the front entrance to my research lab in Navarro County, Navarro Mills Lake. 52 acres, had a 5,200 square foot research lab, concrete steel, 18-foot walls where we could do a mezzanine deck, made it 2-story. It was a beautiful facility. It had every discipline that you can name in that research lab. We had complete machining, fabrication, welding. We had all the optics. We had laser. You go, just name them off. We had everything in that lab. Now, Phil over here and his wife Venice are here from Haltom City. And Phil and Bert Poole of the Fort Worth Tesla Coil builders nicknamed me the King of Salvage. And that goes way back whenever I just got out of the military. I got interested in the alternative energy field, and I figured the best source for all of the goodies to build all this stuff that you guys were thinking of and coming to the conferences and seeing all this is to go to the electronic salvage yards and pick over the goodies. I can proudly say that I single-handedly scrapped the first generation computer system that came out of Cheyenne Mountain. There's no one else can claim that. I did it. And it was all built by Burroughs and those companies. It was so antique in Cheyenne Mountain on that first generation, they used bead core memory. That's how antique that stuff was. But I scrapped it all down. That's how I got started in this game. So collected a lot of goodies to the tune of over 100 tons of stuff that I've accumulated over the years. And it was all pigeonholed in this place. Phil and Bert would come out with their trailers. And he's got 20 tons in his backyard. Venice, you can vouch for that, right? Bert had 10 tons in his garage. And finally, his wife said, Bert, the garage is getting too small. So Phil has been hauling stuff over. So how did we get here? It's an interesting story. I got interested in the cavitation phenomena with the Fernetti disc or rotors that used to make heat for homes. They had rotating drums and they used cavitation to create heating. And they sold these. I think Sears peddled them for some time. So this was late 30s, 40s, something like that. So I got interested in all this technology, and while I was researching it, I got into Perkins rotor, which is one over here, which we're going to cover later, which deals right with what Moray's working on the cavitation phenomena. And the Perkins rotor, Griggs hydrosonic pump. Remember whenever Fusion Facts and Gene Maloff in Infinite Energy was publishing the stuff that NASA had done, that Griggs hydrosonic pump was over Unity. So what I did is I built that unit over here, and I'll explain later how we proved where that energy was coming from that gave him over Unity. And he did get a patent, by the way, for over Unity, but it wasn't on the hydrosonic pump. Perkins was practically his neighbor in Roswell, Georgia. Perkins had priority patent on that rotor right there, and he was granted the over-unity rights on the thing. So, to fill in the story on how we got to this lab, back in 1994, we did a Tesla symposium in Colorado Springs, and Leonard Dorset had super steam. And I did the presentations for Leonard and also did the workshop presentation. And the super steam technology came out of the Farben libraries, the technical libraries that were brought back after World War II. For some strange reason, the tech libraries wound up at SMU University in Dallas. And Professor Brown was fluent in German, and he read through, and he got the technology to build the super steam generators. I was fascinated with this generator, and I worked with Leonard for 2 years prior to this conference here. And one of the things I was always fascinated with is Leonard was very shy when he would start this unit up. It ran on compressed air. He had a big Ingersoll Rand compressor making compressed air. He had the propane, and he had his water supply. And it used a big old long reach Bosch spark plug like you use on a motorcycle for the igniter on the thing, and he had a igniter power pack. And he would always start the thing up, and he kept fouling the spark plugs because he was fogging water in the thing while he was building the fire. And I kept asking him, I said, why do you foul your spark plugs? Why don't you just feed propane and air in the right combustion ratio and fire the thing off and then feed the water to it? He said, oh no, it'll melt down. And I said, wait a minute, what do you mean melt down? He said, it'll do a thermal excursion like this. It goes exponential. Once it happens, it goes straight up. And he said the thing will melt down so fast you can't even turn the fuel off. And I was really puzzled with that. While we were doing demonstrations in Leonard's backyard, and here's a slide from his backyard right here. There's his old Chevy parked in the background. We had a guy by the name of Bob Jeep from down at Waco, from Baylor University, and he was what we call strap hangers. They're the guys that are always around, gleaning the information, trying to find out how things work. Well, Bob went to about 5 of our presentations there, and he took copious notes. He measured every piece of this, and Bob runs off down to Baylor and tells the professor down there in engineering, let's build one of these things. So the professors pooled their money, come up with about $10,000. They built a copy of this. And my friend old Nick Holden down there in the buckyball business, making buckyballs, Nick was there when they fired it off in the parking lot. And he called me and said, Norm, you're not going to believe this. They fired off their super steam generator down there, and as soon as they started it, it belched molten stainless steel right out on the asphalt in the parking lot. And I laughed. I said, well, Leonard was right. That thing will do a thermal excursion like this, and when it does, what happens is when you start making monatomic hydrogen, in this, and you get the mixture just right, the temperatures will go over 10,000 degrees Fahrenheit in that thing, and it'll literally melt itself down, which Bob Jeep melted his. So based on that, I had originally thought about a hydrogen-producing device based on Tesla's. Remember his bulb experiments he was doing? He called it the carbon button, and that he was vaporizing carbon buttons in this lamp, and he was running it at 15 kilohertz and bombarding that button with atoms, atomic bombardment. And he equated it to 1,000,000 ball-peen hammers, whap, 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 making the heat, which would actually boil away a diamond. Well, I got the idea of building the same device with an outer cooling jacket where I could turn my water into steam, high-temperature steam, run the steam in, and have a carbon feed with a 15 kilohertz high voltage, like Tesla did, and actually make the hydrogen from combining the super hot carbon with the disassociated water. in the tables, you can look this up, and it's available on the internet. And I did a lot of research and found that this threshold dissociation temperature for steam, to where you start breaking the bond of the hydrogen-oxygen bond, is at 1700 degrees Fahrenheit. That's the threshold, lower threshold. But the curve goes up very rapidly. And we found out through research and everything that we could run a reactor making hydrogen at 2,000 degrees, and it works best at 3,000 degrees because you get a 100% dissociation of the steam at 3,000 degrees. If you work below that, you're not getting 100%. But to make this thing work, the reactor work, you've got to work perfect stoichiometrics. What I mean by stoichiometrics is you have your carbon feed and your water feed has to be in the perfect ratio. And that stoichiometric ratio is 6 carbons, 12 H2Os, and at 3,000 degrees you'll yield 6 CO2s and 24 H, monatomic H. And that's the way it works. So go a little further here. There's the patent right there, and what we'll do is flip this over here so that you can write this patent number down. It'll take a half hour to go through and read these 24 pages on this patent. But here's the patent number. Write it down. You can load it to your laptop or your computer, and you can read this patent. There's the European patent, and there's the stoichiometric ratio, the formula there that we're working with. Okay, we'll go back over here to the slides.
Did y'all get that? There's going to be a quiz after class.
So what I did is I went over to Louisiana and got some good old cypress. My brother and friends were logging a Hog Lake out of Pineville, Louisiana by the Kraft Paper Company. And they were cutting this cypress out. And I wanted to make a cypress gate because cypress is a perpetual wood. It'll last forever. So I brought that stuff back and I built that gate out there, and it was just Battle Creek Farms up there at the top. Since been replaced. Okay, we built this lab. It's like I said, it's 5,200 square feet and it's 2-story. It's got a mezzanine floor inside. There's the side entrance to the lab. And there is the reactor. Now, when you go to the patent over here, you can get a better idea of the working details in this thing. What we were doing is running steam up in this outer jacket here. Now keep in mind this unit is running 3,000 degrees. It is not made out of metal. It is made out of refractory ceramics. And the final version that we were going to make was made out of carbon. And I was fortunate enough whenever we were going into this, I will explain the workings of this. Let me give you a background how we got to this point. John Maluski, everyone here knows him. I was introduced to him through Ken Hawkins because Ken Hawkins was doing crystal research for communications and everything. John Maluski was doing crystals. So Ken said, well, let's go see John Maluski. So we came up to Albuquerque and we explained the situation. He said, I have the man for you. James Warren of Woodland Hills, California. He wrote the book on high temperature refractory and carbon technology. He worked for Thurcol, the solid rocket boosters for the shuttle and all those programs. Did work for Bendix, developing the disc for the disc brakes on the airplanes and everything. Bendix was real big into the carbon technology, could stand the temperatures. And Jim, I got the referral to go see Jim, so I went to the West Coast and visited Jim in his studio. And he said, I went out looking for hafnium carbide, because hafnium carbide will work up to about 3,500 degrees. And he said, I got something better. We'll just do carbon. Forget about your hafnium carbide. We have something better. So really tweaked Jim's interest. Now, this is in 2001. We go back to the slide where we were doing the workshop for the Tesla Symposium in '94. If you review that video presentation, I clearly state in that video that I had a 1/3 scale prototype of my reactor, this reactor, already machined and welded together and everything, ready to go. This was in 1994. Well, I bought the farm and everything, and in the year 2000, I wrote this patent for this in year 2000. Well, Ken Hawkins was over in Bucharest installing a telecommunication system because that was the business he was in. And his friend was from Berlin looking for lucrative projects to get into because they had investor money. So Ken comes back to Dallas and said, we're going to see John McAllen in Berlin. And he said, get your patent ready and your prototype. So we flew to Berlin in 2001, spring of 2001. Met up with the investor group. We had a prototype with us, the patent. Went to the patent attorney. He looked at my patent as I wrote it, and he said, it's perfect. We're not going to change anything. It is perfect. And they liked the idea and everything, so we came back to the States and went straight out to Carson City, Nevada, set up a Nevada corporation, incorporated, set up the bank accounts, and Wells Fargo. We had everything set to tranche money from Europe, from Berlin banks, into the United States, which is tricky stuff. So had it all set up, money starts flowing. We broke ground on that lab and had the iron up, the concrete poured, the mezzanine floor was poured, but the sheet metal and the roof wasn't on it. Well, guess what happened in 2012? It was 2001, 9/11 hit, World Trade Center. As soon as those buildings went down, the Germans freaked out, and they cut the money off because they thought we were going to go into World War III. So the money stopped. Here I am with a half-finished lab in the fall of 2001. I had gotten a patent on the Sonar diffuser, which I'll cover that later in the presentation, where we put oxygen into water or infuse any gas into any liquid, anything you want to do. It was called an emulsifier diffuser, and we called it a Sonar diffuser because it worked in sonic frequencies, ultrasonic frequencies. So I had that patent. I sold my rights to it, finished the lab, outfitted shops and everything was ready to go. We didn't have any money coming in to do the project. So the people in Berlin visited the Russians. And so happens that Gazprom was drilling and producing a lot of natural gas, which we see it arrive on our shores as LNG, liquefied natural gas. Half of the production of the gas in Russia is sour gas. They cannot liquefy it and sell it. What they were going to do is they wanted my process to convert the sour natural gas into hydrogen and sell the hydrogen to the Germans, because while I was over there, they broke ground on the BMW plant at Dresden, which we burned down during World War II. BMW built the plant at Dresden making hydrogen BMWs. In fact, they brought them to the States. They had them out in Los Angeles out there demonstrating the hydrogen BMW. So everyone wanted to go to a hydrogen economy. So this was ideal for the Russians. So the Russians put up $1.2 million for me to build 2 prototypes and do proof of concept so they could take it back to Russia and clean up their gas and make hydrogen. We tried every trick in the book to sell this technology here in the United States. I personally went to Crawford, Texas while Bush was there, and I handed the documents right into the hands of the Secret Service, and I said, this goes to President Bush. Not one reply. I sent the same package to the White House. The White House mailroom sent me a receipt, signed receipt back that they had received it. I sent the same package to DOE. I gave it to Newt Gingrich, was the Speaker of the House. Met with him personally and bought his book and had him autograph it, and I handed him the whole package. I said, Newt, do something with this. Ku Klux Klan Bird was sitting in West Virginia on all that anthracite coal, and we wanted to clean coal up and make it green friendly by converting basic carbon, which is coal, into hydrogen. Not one peep out of the White House or any of the agencies, nothing, not one word. Whenever the Russians came over to my lab, 6 engineers from Russia flew in. We picked them up in Waco, brought them out to the lab and everything. I sent a letter to the State Department stating that we had Russian engineers were going to be in my lab. I wanted them to heads up so they'll know what was going on. Justice of the Peace in our town there was a personal friend of mine. He said, Norm, there hadn't been one black helicopter. There hadn't been one agent come around and even ask any questions. He said, they don't give a damn. That's right. They didn't give a darn. They didn't care about this project. So that's what happened. The Russians funded this project, and in the spring of 2006, we did proof of concept. They came over, and they observed the whole thing, and they took the thing back to Russia with them. They acquired patent rights because they left me with a beautiful lab, all paid for, all the machinery, everything. Lock, stock, and barrel, that was mine. It was built on my property. I told them when we built it, and we did your research in it, since I'm paying taxes on this land and on that building, it's mine when we get through. And they said, fine. So that's how I wound up with that property. Okay, we're going to get into how this thing works. The reactor is an implosion vortex. And everyone knows about Rank-Hilch. Most people don't know unless they've really studied this. The original first version, which was Rank Vortex, was studied for separating gases based on densities. They separated gases in the labs with this thing, and then along comes Hilch and said, well, there's a refrigeration component on this. You got hot coming out one end, you got cold coming out the other, and they started making two-post cooling, and they did all kinds of stuff. They were using it in the mining industry and everything for miners' suits and everything to cool the suits in deep mining. But most people don't know about the gas separation feature of the original Rank. Well, it fit perfect for what I wanted to do, because what I was going to do, we go back to this slide right here, you see the vortex in there. There is a critical line in this thing, and it's right there, what they call the stagnation line. And that stagnation line is right there. And what happens is, this is where the reversal takes place, and the coal collapses and goes to the core. The hot expands and goes to the outside and discharges as hot air. What happens, though, under Schauberger implosion, we argued this with the patent examiners in Japan. I'll never forget this. Implosion, Schauberger, the heaviest goes to the core, goes to the center. The light goes to the outside. Contrary to centrifugal, it's centripetal. A patent examiner in Japan got our patent because we were going with the European patent, which is on that slide over there. Well, the Japanese got it and said, we got a patent here that is similar to yours, but it contradicts what you're saying. And they're saying that the vortex is centrifugal, and you're saying it's centripetal. I said, right, study Schauberger. So he studied Schauberger, calls me back and said, you're right. So we won that point, and our patent flew in Japan. But that shows you what you can get into unless you study your subject and know what you're talking about. Okay, I want to introduce now Angel Alvarez. This is the point of contact with Vortex Energy Incorporated. He has lovely bride. He brought his lovely bride with him. They flew in here last night at 8 o'clock. And it was the reason I couldn't do the presentation last night, and Moray stepped in, is Angel's flying in, and he's the president of our company, and he wanted to see this presentation. And I told them out there not no, but hell no, because I have a guest coming in from California, and I can't do the presentation last night. So that's what happened last night. Anyway, Angel's here, and that's the point of contact, his email. When you get the DVD, all of this information's in there. Now, we talked about Jim Warren being the master of carbon composite technology. I worked very closely with Jim. In fact, back in 2004, I met Jim, and we went to Carbondale, Illinois, to Southern Illinois University, and installed a vacuum deposition furnace for making carbon composite material. We installed that furnace at the school there at Carbondale. And while we were there, all the physicists grabbed their briefcases, and when we walked in, they were going out the door, and Jim said, "Where are you guys going?" They said, "We have a big meeting with NASA down on the Cape, and we're on our way, because we're going to do the leading edge material on the new space plane." And Jim said, "Well, hell, I'm the king of carbon. You're going to leave me here building your furnace and everything so you can make samples and everything for DOD and NASA." So that's how I got to work with Jim. For the first time, I got up close and personal working with him, installing a furnace for him. So we had that project. So Jim was really excited about this. So what happened is, whenever we got the proof of concept done for Gazprom, and they pick up stakes and they leave, Jim had formed his company called CIC, Composite Innovations Corporation. And off of that, he created VES, which is Vortex Energy Systems, which Angel recently renamed it Vortex Energy right there. And that's a new company that he set up. So all of the marketing, anything that happens with this Vortex technology, or the Vortex Reactor, which makes his hydrogen, will occur under this. What I'm going to do is go into the very last slide presentation, PowerPoint, that Jim did before he died. It's dated March 2012, and Jim passed away in Mother's Day 2012. So this was his last presentation. I'm going to go through these slides rather rapidly because you get the DVD and you won't be able to read them on this screen. This screen's blurry, but you'll be able to read them on the DVD and everything. And see, it goes into detail about how the Vortex Energy System works. It's basically a modular program to where we go in for smaller power plant installations. We do them 60 megawatt modules. And incorporated in this power plant design is the Tesla Turbine Technology for prime movers for drive-in generators. Also, running the vacuum pumps, doing the desal and cleaning up water. Also, using the Tesla Turbine Technology to eliminate cooling towers. The state of California had legislated against cooling towers on all power plants, gas and coal, and excluded the nukes. The nukes could keep their parabolic towers out there. What was happening is you're belching off billions of BTUs into the atmosphere from a cooling tower, much less the loss of water. Jim went around the state of California, and it's in the slide presentation, and determined the amount of water used to generate electricity in the state of California. And he almost fell over when he found out that the daily use of water just associated with power generation in the state of California was 6 times greater than the flow going through Hoover Dam. And California's hurting for water. So they wanted to eliminate cooling towers. We had the perfect technology to go in and eliminate cooling towers and take the heat of condensation and everything, all the sensible heat, and using mechanical vapor recompression technology, which some of you have heard of it and some not. But we were able to capture all of the heat and put it back into the front end of the process and give you another 25% yield of energy over what they were getting, even in a coal-fired power plant or a gas-fired power plant. So that was the nature of the program. And Jim said, okay, what are we going to do about CO2? Because everybody's trying to figure out how to remediate the CO2 from these power plants. So immediately he started researching the Bio Photo Algae Production. And basically what you do with the algae production, it converts the CO2 through algae growth, and you grow an algae that has a high lipid. The lipid is the oil content in the algae, and if you grow an algae that has high lipids, you process it and everything and separate it out of the fluid. You can make biodiesel out of 50% of the algae and make protein for cattle feedstock. It's 100% protein. So I'm going to go through this slide presentation real quick like this, and you can read. It would take an hour for you to read this thing. So get it on the DVD and you can read it. So this is his slide presentation, his Vortex Energy System. This is dated March of 2012, the last presentation he made. And it's all print, you can't read it, but we're going to go rapidly through this. And doing this, we'll get it on the DVD. And he explains the vortex in nature, the tornadoes. You get the wingtip vortices off of aircraft and everything. He explains all of the natural occurrences of the vortex. And it's implosive in nature. Anytime you go from a high pressure to a low pressure, it's implosive. Like if you pull the stopper out of your bathtub and the water runs down the drain, it'll run around in a vortex, and that's an implosion vortex. We'll go through these slides and we're going to get into some real interesting stuff. We get down here, and that's a Hilch vortex, and he explains that. He gets into the Tesla turbine and explains the Tesla turbine and its application in this program. He gets into some of the finer details in here on the turbine. There's a clicker. There we go. Now I'm going to just go through these quick because you can't really read them on this screen. But on a computer screen, they work perfect. You can read. There's flow diagrams for the plant. A lot of technical detail. There's a plant with a cooling tower and one without over there at the top. And then he has down here, he has a footprint of one of our power plants right here, a 60 megawatt power plant, and it reduces the footprint of that thing down to about 1/10 of what you would normally see in a 60 megawatt power plant. And the blue container deals down there are the algae bioreactors, and I'll explain how those things work. And there's a artist concept of one of our power plants. It's a lengthy slide presentation, and it was made for investors to explain. Now, this is Jim Warren. Let's see. This is Jim Warren's right here. That's his resume. The next resume here is Angel Alvarez. These guys have such an extensive background in not only civil engineering, but also in the military and NASA. I mean, you read Jim Warren's resume and you said, holy crap, how did he do all of that? But it was really, really interesting whenever you read it. And mine down here, I'm the inventor. I'm the idea guy in here. And he goes, the old man in the sea slides up here, you know, whenever back there when they were studying. Now, in here, whenever you look at this slide, all across here, this stuff is all Tesla turbines up here. That's all Tesla turbines. You got a Tesla turbine prime mover driving vacuum pumps. This is a desalinization plant. Now, I went to Dubai and studied their systems that they were using over there. And they use motive steam, high pressure motive steam, through an eductor to make their vacuum. So they got a tremendous steam requirement. And we studied theirs, came back, and we designed ours using the the Tesla units right here. We have refrigeration down here doing the condensation and all. And we got a Tesla turbine driving a generator down here. But it was really interesting. We compared the state of the art, what they're using in Dubai now to make their distilled water from Arabian Sea or the Persian Gulf. They make all their water, and they've got these huge desal plants over there because they're in the desert and they have very little rain. Now, this is something that we got into on mechanical vapor recompression technology. This is state-of-the-art heat pumping. And with this, you can get just a medium lift, lifting from one temperature to another, what we call a medium lift. A high lift is what you get whenever you have your heat pump sitting out in your backyard cooling your house. That's a high lift because you're working the refrigerant on that. You can get COPs, they're approaching like maybe 8-to-1 right now. They used to be about 6-to-1 on heat pumps. And we were getting on this 20-to-1 on a medium lift. And we did it in cascade, in stages. And each stage has a different type of refrigerant that works at different temperatures. And what we were doing is using this vapor recompression to make our refrigerant, high pressure refrigerant that drives the Tesla turbines. We didn't use water. A Tesla turbine was designed by Tesla to operate on a condensable fluid in a closed circuit, which means you vaporize on this side, you make high pressure steam. He advocated using 120 psi and using the Dela valve to accelerate. I'll explain the Dela valve when we get into the Tesla turbine. But we were using this cascade 3-stage right here with the different refrigerants to make the high pressure refrigerant. Our prototypes ran under 123, refrigerant 123, which was ideal for this situation here because we wanted an output pressure at 120 psi, but we wanted to go into a 40-degree condenser, and the gas just immediately collapsed after it came out of the Tesla turbine. So technically, you were running your condenser in a vacuum. The high pressure side at 120 psi, you got a vacuum on the condenser side. Worked perfect. Tesla turbine. We're going to talk about improvements to the Tesla turbine that no one has picked up on yet. That right there, you can't read it, but in 1994, I wrote a patent disclosure and sent it to the patent office, got it back, and basically, I'll go through these slides right here. You can't see it, but we'll handle the real thing over here. But what we did is came up with a way of using a basket right there for the disc to mount on to where, and had seals on both ends to where all of the motive gas that you were driving the turbine had to go through the disc. It didn't have, I'll show you what they were doing, and they're still doing it. There's the hub right here of this unit, and they have seals on both ends. So the only see the labyrinth seals that are machined in here? This is one of the ones off the internet right here. That right there is machined in, and they call labyrinth seals. They run in those grooves like that. And it's like Tesla's one-way valve that he had, where the gas would go through it one way like a gas diode. And that's the way that valve, the labyrinth seals work. It had a very treacherous path to go through, so the gas would prefer to go through the rotor rather than go through those seals. So that's the old technology, and we did this patent disclosure. And when I came up here to do dump off a truckload of stuff to the Tesla Museum in 1995, I emptied my lab and I brought everything I had up there and I donated it to Tesla Museum. I had Wimshurst generators, I had Holtz machines, I had Van de Graaff, I had Adams motors, I had a whole slew of stuff that I donated to the museum. And then Dennis Lee, when they declared bankruptcy, Dennis Lee comes in and buys everything for $5,000. under a bankruptcy sale, lock, stock, and barrel. And some of my stuff still appears on Dennis Lee's site. Okay, here's the key to the Tesla turbine. And most people don't understand this. They'll take and make a jet blow in the air or whatever, an emotive fluid onto the disc. They don't understand that Tesla and De Laval, he knew De Laval through Alice Chalmer up there. Alice Chalmer was building the turbines, the steam turbines, and they used De Laval. So Tesla actually went to Milwaukee, up there to the Alice Chalmer, and worked with them on developing his turbine that Alice Chalmer tested to the tune of like 600 horsepower. And they used these De Laval nozzles. There's the nozzle right there. And this is in a modern steam turbine right here. What you're doing is accelerating this gas, this steam, to supersonic speeds before you introduce it into the buckets. Now, the way this thing works, there is the curve. This is the key to De Laval. Now, Robert Goddard, the father of rocketry, he even taught the Germans a few things about rocketry, because way back, whenever De Laval came up with this and Goddard first started building rockets, he couldn't get any thrust out of them. So he got a hold of the De Laval, and what happens here is, see that temperature line right there? And see that pressure line? What are those called? They're potential. You got two potentials right there. What happens is, when they cross through this throat right here, all right, there's one condition that you have to achieve before you can merge these two lines right here. When those two lines merge right here, there's a blue line that you can't see right here that's going up right there. What you're doing is, when you get to this part right here, you're 99% conversion of pressure and thermal potential into pure kinetic energy. You got a high velocity mass gas called kinetic energy. You're converting two potentials into kinetic, and that's the way a De Laval nozzle works. Now, to get this condition right here, you have to choke the throat right in here. And what they mean by choking the throat, you adjust the back pressure out here to the incoming pressure on this side, and you get the correct balance. And what happens is, these gases go supersonic. And as soon as they go greater than Mach 1, the sound waves are trying to come back through the nozzle, but they can't, because they're blocked, because it's supersonic. So what you get is a packing, sonic packing of that nozzle. And then that's when it really takes off and goes supersonic. And they've got all kind of parameters you can design around to make this thing achieve the maximum thrust. Now you'll say, okay, you start off at sea level and you got 2992 barometric pressure. And a rocket starts up and it gets out here close to the edge of space. You don't have any back pressure. Well, what they did was they designed a choke in here, a variable plug, that they could plug this thing and control the back pressure to achieve gas velocities coming out of the De Laval nozzle here at like Mach 15 and getting maximum thrust, even if you're out in the supposedly a vacuum of space. But they used a choke in the nozzle like that to maintain that supersonic flow. And that's how a De Laval works. And without that flow, the Tesla turbine won't work properly. Now, the reason why Tesla designed his turbine with perfectly smooth disc, they had a mirror finish. And the reason for this is the smoother a surface is, the more adhesive the boundary layer. You got a boundary layer that really sticks. It's like glue. Okay? So that's why the discs have to be as smooth as you can get them. And Jim had designed our discs using carbon, and they look like a sheet of glass. What happens whenever you're taking a gas at supersonic velocity and injected into this pack with the de Laval nozzles injected in there. At a point inside of the pack, in between the disc, the gas slows down, or the steam, whatever you're driving it with, slows down. And when it starts to slow down, what you do is you're backing into subsonic. And this is what happened. I didn't mean to do that. What happens is you start forming a shock wave. Now, on each side of the disc, you form an equal shock wave like this, because the fluid is trying to go subsonic, and you nail a shock wave on there, and the shock wave adhering to that boundary layer is what gives you the driving force on that disc. It's like having an air brake out there, and that high velocity gas, it's driving that disc, and that's the way the thing works, but most people don't understand that. I've seen very few people build Tesla turbines and actually use a de Laval nozzle. And that's the way it works. It's on the shock wave. Now, up here, you have a little nozzle right here, and it's like ours was built with a comb. It's like a comb. And in the grooves in the comb like that, you have the de Laval nozzle in here with the taper ratios, and it's all figured out to where you're getting that shock wave developed in between the discs driving that. And naturally you have the implosion vortex. It's implosion because it all spirals down and goes into the core and exits in the core. And they have the exhaust out here. You have the inlet right here in these sprays. And that's basically how the turbine works. That was my turbine bench in the lab that I showed you. There's some of the hard drives. Those are 340 meg hard drives there. We took them apart. We have the disk. Some of the discs are right here we took out of there. And the hub's laying right there on the table that I machined. And it has on this one, whenever you install this plate right here and seal this off, all of the gas that you put in between the disc here driving this comes out through this hub right here, through that hole right here. And the other end is sealed. You got a seal running here. But now, if you take this plate off right here, and if you ever tear down hard drives and you wonder, well, how do they seal that thing and have a frictionless seal? It's simple. Called ferrofluid. Ferrofluid is a totally friction. All of your hard drives, you tear them apart, look, and they have a ferrofluid seal. And with a ferrofluid seal, you can buy these things 3-inch diameter. I can put a ferrofluid seal here, and the exhaust of this thing is 3 inches coming out of here instead of 7/8 right here.
Norm, you can set that on the presenter at the Elmo there, and they can look at it.
Say again?
You can set it on the presenter there.
Well, that thing won't focus on this 3D image here. Anyway, that's how those. Oh, she's already got that slide up there. Okay, that was the Tesla turbine bench out in my shop out there. And before I had this shop, I built the one I donated to the museum. It had a real neat one I gave the museum. It had a little alternator on the top. You could run it on, I use CO2, the liquid CO2, because you could run it a long time on a 1800 PSI liquid CO2 bottle. And I had a regulator on it. We were running at 120 pounds pressure. We'd run the turbine and it would all light up. We had lights inside to where you could look and see how it all worked in there. It was really neat. Dennis Lee wound up with it. Okay, next thing we're going to go into is the MRA. This is probably the most controversial thing that came along. Back in 1994, actually December 94, we did a formal presentation of the magnetic resonant amplifier. And immediately, as soon as we demonstrated this thing, there it is. That was version number 1. Now, some of you electronics guys will look at this and recognize the old Hewlett-Packard vacuum tube signal generator. That is a HP 200 CD. By the manual from Hewlett-Packard, that thing was capable of 1 watt. It was a vacuum tube amplifier. It put out 1 watt. Our very first version that we put on the Keeley net, and they put it right out on the internet, and it caused havoc. Look at the figures down here. We were running the gain off that signal generator at 60%. That was with equivalent resistance. We measured the input to the MRA at 0.685 watts. On the output, to eliminate any argument with these strap hangers out there, we said, all right, we're working this thing at 32 kilohertz, okay? High audio frequencies. And we had a barium ferrite core, we had a lead titanate crystal, a piezo, and we had a 1-to-1 winding on this original, very first one. And it was crudely wound with number 18 THHN wire. And we wound this thing. We did a full wave bridge to rectify it to DC. We put a 2 microfarad filter cap. You could put the scope on there, and it was flat ash line DC that was coming out of this. 2.75 watts measured DC with a 0.685, which gave you a 4-to-1 over unity ratio. What happened whenever this thing hit the internet, I mean, we were just a deluge of emails. Everybody's up in the air, you know, this is impossible. Well, it so happened that we had a man in Atlanta. Bob Taylor was an investor. He was a builder, built homes around Atlanta, and he was Roswell, Georgia. He was working on a similar idea, and he saw ours on the internet, and we dumped it, and we published it as, we're giving this to the world. We don't want anything. We're giving it away. You take it, build it, and do whatever you want with it. We just gave it away. We didn't want to get in any trouble with the thing, for the implications, because you're looking at another cold fusion fiasco whenever you come out and talk about this. As soon as Bob Taylor saw it, ring, ring, he calls us and said, can you come to Atlanta and bring everything you have on the MRA to do a presentation? And I said, fine. We load up my pickup. Phil was involved with us back then. Loaded up my pickup, and we go to Roswell, Georgia, and get to his office. And he said, I hope you don't mind, but I have some gentlemen here that want to observe this demonstration on the MRA. And I said, fine. He introduced us to the financial guru for IBM Corporation, the head of procurement from IBM. And the man was retiring. And he said, I would love to have a feather in my hat when I retire. He said, we're really interested in this. Demonstrated. He had 2 EE engineers from IBM with him. We set it all up, ran it through the paces and everything, and they said, holy crap, you got to be kidding me. And they said, get the patent on the thing, apply for the patent, get the patent, we want to buy it. He said, I have a blank check that we want this for computer, laptop computers, cell phones, everything for battery, perpetual battery, using this technology. So, yes, sir. So Taylor, we've signed contracts with Taylor and everything. We started the patenting process. And Dr. Robert Bass, he was voted Physicist of the Year in 2003. Dr. Bass was our patent attorney, and we got the ball rolling. Well, Taylor had the MRI, as you see it right here. He gets all anxious and everything, and he goes over to Concordant Industries there in Atlanta, and he said, put this on your test bench and see what you come up with. They tested it 10-to-1 over Unity. He said, okay. He goes down the road to Scientific Atlanta. Everyone here knows who Scientific Atlanta is. They make all the long-haul communication dishes and all of the head-end gear on long-haul communications. So they take it into their physics lab and everything. They had a different version. They test it. They get 10-to-1. And they said, sign an affidavit to that. And they said, no, we're not going to do that because we got our company reputation to consider here. So in the meantime, we took a version of this and sent it down to Hal Putoff down at Austin. And everyone knows the background behind Hal Putoff. He's a great man and everything. And he issued the 1 watt challenge for anybody that can build something that was self-running that would produce a 1 watt excess power. Well, this didn't meet that criteria because it's not self-runner. But we wanted him to test it to see if it in fact was over Unity. Well, he was testing it down there, and for days after days, he was looking at the same thing we were looking at, over Unity, and he couldn't explain it. And he is the man that issued the challenge. So what he did was put a lump resistance in the primary of this circuit. He put a lump resistance in here, and we'll go into what happens. See that curve right here? For the MRA to work, you have to work right there. And that is called the zero loss or lossless region on the resonant curve. You've got to operate it up in this region right here. You put a lump resistance in the circuit, you chop the top off of this, and it becomes a common old resonant circuit. And you put resistance in a resonant circuit to broaden the bandwidth whenever you want to put information on a wave like this, a carrier. That's how you establish bandwidth, by putting a lump resistance. Well, he publishes on the internet that this thing was only 50% of Unity. Well, that killed the MRA worldwide. Boom. Hal Putoff said it's 50%. That killed it technically. Nobody was interested. Well, it doesn't work. So Newt Gingrich, Speaker of the House, personal friend of Taylor, Newt says, we'll take your device. I'll take it over to Georgia Tech, to their physics lab, and let them test it. So physics department takes it in. They said, okay, we're going to operate it exactly what you prescribed right there. You got to operate it in that resonant. You can't play around with this circuit. You've got to operate it as you specify to get the over Unity. So they get it in their lab, and they're running it and everything, and they're getting a solid 18-to-1 over Unity out of the version we sent them. And the lead guy said, Hal Putoff's report of 50% Unity, 50%, he said, you can't make the MRA that bad. So what he did is he took the transformer out of the thing, which is crudely wound, took it out of the circuit, and tested the transfer of energy from primary to secondary with a crude transformer. It tested 19% efficiency. Okay, 19%. But he's getting 18-to-1 out of the thing. He said, we can't explain what's going on here, but it damn sure works. Taylor said, all right, will you testify to the patent office that this thing is 18-to-1? They said, no. Reputation of the school. He said, we went through the cold fusion fiasco with Stanley Pons, that bunch, and he said, we will not subject the university to the flack that's going to come from this. He said, we'll sign off. Even though your transformer is only 19% efficient, we'll sign bottom line that it's 99.9% efficient. And he said, tongue-in-cheek, I'm telling you that there's something weird going on here, but we don't know how it works. So that's how we wound up out of Georgia Tech University with a good solid report, 18-to-1. Next stop was along the line. We went to Teledyne Rhine with a different version. They got 6-to-1, and they documented it as over Unity. And the final version that we did, there's the sine waves on the scope. We're using the analog scope. We're using some very good scopes on this. We had, you name it, I had a palette of oscilloscopes. And there's tuning. And look at all of the rich harmonics you're getting in here, and these sine waves right here. And the final tuning, this is just one of the versions. The final tuning looked like this. The curly Q, the heavy curly Q is current. The brighter, higher peak there is your voltage. Now, we were operating this thing slightly inductive, and somebody that's smart out here is going to say, you've got a capacitive picture up there. That's capacitive. Well, we made up the slides. We made a little mistake, and the slide was flipped upside down. So if you want to look at it as inductive, get up out of your chair, turn around and look between your legs at the thing, and it'll be an inductive curve, okay? That's the solution to that. He already had the slides, so I couldn't call him, turn that slide over. But anyway, you get into some of the technicalities there. There was my MRA bench out there in the research lab. I had one of everything that you could name in there. Like I said, I had a pallet of oscilloscopes. They were everywhere. So we did a lot of interesting research in there, including the crystal technology that Ken Hawkins was working with Dr. John Maluski. So that was the story of the MRA. Now, bottom line, let me tell you what happened at the patent office. Bob Bass called the patent office on the week that they were going to issue the patent. And he said, what's the status? And the head of the patent office got on the phone and said, we're not going to issue the patent. And he said, what is your reason for rejection? They said, we're not going to reject it. Bass said, you're kidding me. He said, you got to, if you're not going to issue it, you got to reject it. Give me a reason. He said, we're not going to do either. We're going to lock it in the file cabinet forevermore. Sue us. That was the head of the patent office said, Bob, sue us. And that was the end of that. It's still locked in a drawer in the patent office. Okay, Leadville Tesla coil. Everybody wants to know what happened to the old Goka Tesla coil. What happened is out here at Leadville, Toby Groats and that bunch out there were working with Golka after he moved down from Wendover. They set this thing up in the big steel building up on the mountain over here at Leadville, and he was running it, and he wanted to tap the atmosphere, the high ionosphere and everything for energy and all. He did his work out there, and what happened is he got a deal with Epcot Center in Orlando, Disney World, to bring the Tesla coil down and set it up in Epcot Center down there for a lightning show, okay? Boy, Golka got all fired up. They loaded everything they had at Leadville in 2 semi-trailers. Drivers take off. Golka's headed down to the Disney World, and all of a sudden they get a phone call, cease and desist. Well, to operate that coil inside of that big geodesic dome down at Epcot Center down there, there's some insurance ramifications. Lloyd's of London said not no, but hell no. So here's 2 semis en route on I-40. They catch the drivers in Memphis. They said drop the trailers in the yard at Memphis, which the drivers did. So here's the trailer sitting there. Golka doesn't have a dime. He put every dime he had into moving that stuff down to the Disney World. So the trailer's set in the yard up there in Memphis, and the people said, if you don't come get them, we're going to scrap them. So Ken Hawkins gets 2 semi-drivers to deliver the trailers down to Mortimer's scrap yard, salvage yard, down at I-10 and I-45, right there in that curve. And Mortimer was buying surplus out of Fort Hood, down in Johnson Space Center. He was going all over. And he had yard, you name it, he had it out in that yard. So they parked those 2 trailers in there, and they sat there for years, out in the sun, locked up. And we went down and looked at it, and Mortimer died. They were clearing the yard to build a big building in there, so Ken Hawkins hired 2 semi-drivers to move them from Houston to Sherman, Texas, to Perrin Air Force Base, which became Grayson County Industrial Airport, and he parked them on the tarmac out there. And when he moved them, he noticed that oil's dripping out of the semi-trailer that had the transformers on it. Well, it doesn't take long for the county inspectors to come over, and they take a sample of oil dripping on the asphalt, and it's PCB oil. Because the transformers are made in the late 30s, 40s, all PCB paraffin-based oil. So they told him, get them damn things out of here. So Hawkins had no place to put them, but I had 52 acres of land. So he hires the semi-drivers. They brought them out to my farm, and they sat out there in the bright sun out there for 5 years. And needless to say, they're dripping oil. It got worse and worse. You'd open the trailer, and the floor was saturated with this oil coming out of these transformers. So I told Ken, I said, I'm going to sell the farm. We get through with our project with the Gazprom. I'm going to sell this, and I'm moving. You've got to get them out of here. And boy, he bickered, and he calls Goka up there in Boston, and Goka didn't have a dime. And Ken said, if you get anything out of those trailers, you're going to pay me for what I have in those things, moving them around for the last 10 years. And Goka didn't have any money, so Ken finally gave up. One day he shows up with a 16-foot flatbed trailer, and he and his son-in-law and friends, they go in the trailers and they strip every piece of copper, the primary coils, the cables, and all the secondaries, you know, the 8-gauge, great big wood spools of copper. I imagine there was maybe 3,000 or 4,000 pounds of copper on those trailers, but they got all the copper. And they left. And I said, what are you going to do with the rest of this stuff? He said, it's yours. Here I am sitting with 14 transformers that are leaking in these things, leaking PCB oil out on my ground. So I said, to hell with this. So I started pulling those things out, and I would drain the oil, and I had 40 55-gallon drums of PCB oil out there, and the farmers around the area are burning brush piles, and they said, boy, that stuff burns like gasoline. So they burned it all up, and I got rid of the PCB oil. But I salvaged out all the copper. We salvaged out everything in those semi-trailers. Then Ken Hawkins shows up and said, I'm going to sell the trailers. That's what I want out of this. So he sold the 2 trailers for $1,500 to a farmer. Goka's up there in Boston crying because all of my life work's gone. So that's the disposition of the Leadville coils. So when I took the transformers and pulled the guts out of them, after I drained the oil, you look in the very bottom, the PCB oil sitting out in the sun, they would get hot and get cold, get hot and cold. The transformers have vents on them, and they breathe. They're not sealed. But every time they inhale and exhale, water vapor goes in, and it condenses, it goes right to the bottom. There was pools of water in the bottom of these transformers. And with the ingredients of the oil, it made blisters, and they ate through the steel, and it made them leak. Okay. But that's what happened to the Leadville project. Dr. John Maluski. These are controlled data. I scrapped hundreds and hundreds of these drives right here. There's a drive right there, and you have a linear motor that runs in and out driving the read-write heads in here. There's the quarter cylindrical magnet sections right here. Perfect fit around a 2-liter bottle. Thin wall PVC. You clamp these things on here, wind the tape around it like that, and you got a very powerful magnetic field around here. Now, mine right here, that has 4 of those sections. Each one of these has 12 magnets on this. Mine is completely filled with magnets. I got stingy when I was making these for friends and skimped on the magnets and went to 4 magnet sections right there. There it is right there. That's this unit right here. Make magnetic water. See my hair? I took my hat off. John Maluski told me when I went to visit him, he said, if you drink my magnet water, your hair will be like my wife's plants out there. Because he fed them the magnet water out there. And that's her flower garden out there, off of magnetic water. My hair really hadn't turned gray yet. I don't color it. So I think he was right about that. All right, we get into the hydrosonic pump. What happened was whenever Griggs had his hydrosonic pump down at NASA and they tested it over Unity, we wanted to know why that thing tested over Unity. What I did is I built this Perkins rotor, and you'll appreciate this more, Ray, because this is clear glass to where when you're running this little DC setup right here, turning this Perkins rotor at 3,000 RPM, and this is filled with distilled water, just as you see it right here. When you put water in your blender and you turn it on puree, and all you do is it's white, totally white. Well, what's happening in there, if you take a helium neon laser and shine it in here while this thing's running with this white froth in here, and at the same time you bathe it with helium neon laser, you take a high-speed strobe set on like 12K strobing, you stop action everything that's going on in here. Based on the RPM you turn in it, you can stop motion this, and when you stop motion, the activity that's going on in that white froth, this is what you get. This thing is just billions of these little tornadoes right here. But whenever under this strobe light, you stop action, freeze it, and this is what it looks like. You got one end of this funnel, which is attached out here to that glass stator. You got the other end right here that's attached to the rotor right here. And at this focal point where the two cones come together, you got an implosion event right here that emits photons in the violet-blue spectrum. And what happens here, most people don't know that an implosion vortex, if it goes to a needle point, the pressures go to infinity. It's infinite pressure. Within an infinite pressure in water, what you're doing is you're taking the water molecules and you're disassociating them into monatomic hydrogen and monatomic oxygen. It's a disassociation. But whenever they ignite and recombine and burn, actually you get a burn in there, it emits the photons in the UV spectrum. And that, you can run that thing. In fact, when I leave here, I think I'm going to give it to you, Moray, to play with. Okay? And you can look for yourself. Just go out and get you a good, high-quality strobe to where you can work at about 10 to 15 to 20K burst with the violet light on that. You'll see this stop motion right here. But that is the implosion event that we get in this. What it explained what Moray was saying is that event right here is bringing etheric energy into the equation here. And that's why the thing can come out 140%, tested by NASA. You believe it, Moray? Okay, as a result of that, what I did was patented a Sonar diffuser. And this diffuser, can you flip over to this projector here? There you go. There's the patent number of it right there, and that's my Sonar diffuser. And what this thing did was put oxygen into water. We did oxygen first, but you can do any gas into any liquid. And it used that technology over there with the drilled ports in the rotor, and we were introducing oxygen into the rotor and stator, and doing that microcavitation, we were imprinting the oxygen into water, where we were getting 60 milligrams of concentration, which is 600%, and it was persistent. We sent samples out to the University of Texas at Arlington and also North Texas at Denton, and those chemistry department out there said, it's persistent, the oxygen in the water. Well, we can't explain how it's doing it. It's micro bubbles, right? That's the way it works. But we got the patent on this, and I sold my patent rights, and this patent right here finished the lab, and that's where we got the money to build that nice lab out there and finish it. Okay, let's see. We need to flip back the slides again. Okay, this last slide, you can't read it, but I'll tell you where to go. In the Colorado Springs notes, open it up. Everyone that gets their copy of the Colorado Springs notes, you know what I'm talking about. First thing they do is they skip over the foreword, they skip over the introduction, and they go right to 1901 at Colorado Springs, okay? And they start reading, oh boy, we're going to learn how to transmit wireless power. It so happened that the very first depiction in the introduction is two pictures, and this one right here is the most important, because in this, Tesla outlined experiments from the Houston Street Lab when he was doing experiments with telegraphy. He was into telegraphy before he got into communications with Tesla technology. He was able to take his spelled out right in here, 1/20,000th of an amp of DC pulse into the earth. He could send a signal that you could go to a remote receiver out there and receive 1/20,000, 20 milliamps of DC pulse. And the way he did it was close akin to what we did with the MRA. And when you go to your Colorado Springs notes, go to page 25 and read this for yourself. He depicted his batteries up here and down here. You can't see it. But what he did is he took a permanent magnet, cylindrical section like this right here, and he specified that this winding on here had to be very, very fine wire. Very fine, okay? And the reason why it had to be very fine is he had a little tube at the top of this thing up here, above this permanent magnet coil. The tube was designed, a little evacuated tube, to where with 200 volt potential with DC off the batteries, the thing would break over at 200 volts. What he would do is take a variable resistor and back it down to where it was right on the ragged edge of breaking over and conducting. And what was keeping it from conducting was the permanent magnet. The flux from the permanent magnet, it was like his magnetic quench gap. It couldn't fire because of the magnetic field. What he did when he would pulse that relay, like doing telegraphy, you punched the relay, it dropped the flux on the magnetic field using the technology when he used in New York, when he powered the city with AC, but all of the street lights were still DC. He said, oh, it's easy. We don't have diodes in those days, so what he did is he made a magnetic rectifier and operated the DC street lights off of the AC grid. And he said, okay, I'll use the same technology here. And by momentarily dropping the magnetic flux like he did in his magnetic rectifier, it caused the tube to conduct momentarily. But as soon as that magnetic flux popped back, it would cease to conduct. So what you did is sent a DC pulse into the ground. But that DC pulse was called a uni-directional DC, since the magnet field quenched to prevent any ring back. It was unidirectional, like punch, 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 punch. Well, there's where your EMP comes from. If you punch Mother Earth with a pulse, there is a response. And that's Dr. Malusky's magnetoelectric effect. And that's where it came from, right there. So if you'll get your Colorado Springs notes, read that and understand what he was doing. He was telling you how Wardenclyffe was going to work and how Colorado Springs was going to work. He even pulsing the ground rhythmically like that, pulsing DC, not AC. He was able to get a response. He could take a bulb and stick it in the ground out there half mile away and it would light. People walking around out there when he was running this experiment, they had like sparks flying off their shoes, okay? But that's the response from the ground. And I call it neutral spike, and I'm heavy into the neutral spike research and how that works. I was able to replicate or reproduce the EMP event. Remember we got into the study in the sun, the magnetic ropes, they call them ropes. Well, they did this with the X-ray and ultraviolet satellites we have out there, studying how the solar storms work and the magnetic storms. And they've got these tentacles of loops of magnetic flux that come out. Well, if they break like this and reconnect, you get an EMP shot, bam, and it's magnetoelectric like John Malusky described. Well, I was able to replicate this in the lab by taking, of all things, a 5 horsepower air conditioning compressor. And you have to use an air conditioning compressor because an ordinary 5 horsepower electric motor does not have the necessary windings in it to do this. You have to have a start winding and a run winding. You have to have a start cap and a run cap, okay? Take them compressor that runs single phase, 208, 230, 240 volts, single phase. Go into that contactor on there, you got L1, you got L2, no neutral. No neutral is the key, no neutral. So what you have is you have L1, L2, 208, 230, whatever. You have the motor, you've got to set it up in a locked rotor configuration. And you do this purposely because what you want to do, when you energize the contactor, you want instantly to drive your iron in the motor. The rotor iron and the stator iron, it's locked rotor. You want to drive it into supersaturation. If you look at the magnetization curve, the BH curve, you can see where you go into supersaturation, and it's all current after that, hogging current. Because the magnetic flux can't go any higher because the iron is loaded. And you got an inductor that's loaded. Well, you got two capacitors sitting there loaded. Your run and start capacitors are loaded. Whenever you overload relay, you put an overload relay on there, so when you go in supersaturation, this 5 horsepower motor hits lock rotor rated current, which is like 82 amps of lock rotor current, and that's where it's going to stop, at lock rotor. You want to open the contactor when you get it into that supersaturation condition. When you open the contactor, what do you have? You have an isolated charge in that iron. Okay, that inductor is loaded with magnetic flux. The capacitors are loaded, and the capacitors dump through the windings in there, and you get the anti-parallel flux annihilation phenomena. And what happens is you get an EMP in the ground that's violent. I mean, it stings. And at the same time, everywhere around you within 100 yards radius, every single pole motor that's plugged in, not even turned in, just plugged in with neutral only, hooked up. The EMP pulse comes out of the ground and will make that shaded pole motor run backwards at about 10 times its rated RPM and not hurt the motor. You can have a shaded pole motor with little old, like 22 gauge or maybe 26, 28 gauge winding, and that thing will take off like 5,000 RPM running backwards, and after it's all said and done, you can turn the thing on and sit there and run perfectly normal. Never hurt the windings in that thing. And that is what EMP does. It is magnetoelectric, and it's almost instantaneous, just like John Malusky said. The speed of light squared. It's bam. And it's the same thing you get with Tesla's action at a distance when he was making his disruptor coil. I built one in the lab, tested it and everything, and fired it using unidirectional DC with the quench spark gap to get the unidirectional. And it does exactly what Tesla said. When you fire the thing, you get a stinging sensation like you get a needles driven in you. It's a sting that you get from the thing. And electronics in the immediate vicinity like that, they're crispy critter. But that's how the EMP works. And you can do it so easily in the lab. But the 5 horsepower refrigeration compressor is the most simple, straightforward. You can go down and get a compressor, capacitors, hook it all up with a overload relay that'll disrupt the current when it's at peak saturation, and bam, you've got a pulse. And it always manifests out of the ground. Now, I found this to be true. I had installed a projector lift and a screen in a lady's house. She just remodeled, and Miss Sharp owned Sharp Hardware in Dallas, in Highland Park of all places. She was a wealthy old lady. We installed all this nice stuff in her den, and after we got it all put in, about a week later she called and said, "Norm, come over. I got a poltergeist in my house." I said, "Okay, Miss Sharp." So I go over there and I said, "What's going on?" She said, "You sit right there." Sit in this overstuffed chair and everything. She brings me a cup of tea. She said, "You sit right there." And while I'm sitting there, this screen goes, starts down, and the projector lift starts down. Well, those are shaded pole motors that are on a limit switch. It stops them. Either up or down, they'll stop on a limit switch. So the only thing connected to those motors is the neutral. because the hot's disconnected. So this thing does this motion, and she said, see, there's my poltergeist. I said, okay, Miss Sharp. So I'm walking around the house trying to figure this thing out, and I walked past her kitchen, and another one of these neutral spikes occurred, and her blender was on the counter there in the kitchen, and the thing goes, zing! It takes off running, and it's running backwards. And I said, oh, this is really weird. So while I'm walking around, I walk past the picture window looking out to the backyard, and there's two brand new Carrier 5-ton air conditioners, single phase air conditioning unit sitting out there. And I went in and said, Miss Sharp, when did they put those in? She said, they just put them in here last week. I said, uh-oh. So I stood right there and watched, and sure enough, one of those Carrier air conditioners goes, oh, like that. Locked rotor, trying to roll off and start, but the rotor was locked because they had overcharged it with refrigerant. So when it did that, that blender takes off and everything, and I said, there's where that's coming from. That ground spike is coming from that AC unit. I said, if they'll put a hard start kit on there and straighten that out, that'll get rid of your problem. Sure enough, they came over and they fixed her air conditioner, put a hard start kit on it, solved the whole problem. But I remembered, so I was able to go in the shop and set the thing up and do the same thing, which you can do very easily. Let's see, I think we have completely expired this presentation, and we'll take some questions, whatever questions you have. This stuff is up here. You can come up and touchy-feely, do whatever you want and everything, because I brought this in. This unit right here, that was my first work with cold fusion. That is the Mills double nickel. I made it octo nickel because what I did is Bert Poole went to Canada, the Tesla group there. He goes to Canada and he said, Norm, you need nickel, I'll bring you back Canadian quarters. They're 100% pure nickel. I said, oh, great. So he brings a pocket full of them, and there it is right there. That's an octanickel cell. The story behind this is how we got into elemental replication and all this stuff, which we could go on and on and on telling stories because, like I said, I built one of everything that you can imagine, plus I built two of some of them. But in this thing, what happened was I set this thing up, and it's all instrumented. You got your fluke meter on here for temperature, and you can monitor the temperature. And we're driving this, and we're using a little jet right here, and we're reburning the HHO coming off of this and sublimating tungsten to prove that it's actually monatomic hydrogen that'll sublimate tungsten. And we're demonstrating this, and you could monitor the temperature rise in this, and it worked out just like they said in cold fusion. You get an anomalous heat energy over what you're putting in DC power driving this cell. So is it real cold fusion or what? So while I was taking this thing to the science exhibit, it was in the back of my car and it spilled. And I was using potassium carbonate in here for my electrolyte, and I spilled that little beaker in there, and it only had about half the electrolyte left. So I run over to the restroom and I get some chlorinated water out of the tap. And I put it in there and refilled it, and I said, well, we can do this demo. So I fired it up, boy, had the meter on there, looking at the temperatures, explaining the burn here, or the burning the gas and all that. And it was perking, and I looked over at the fluke meter, and it started off at 85-degree temperature on the water in here, and the temperature is going down. I said, wait a minute, we're putting in watts in here off the DC power supply, temperature can't go down. It steadily went down way below the ambient temperature. And I said, uh-oh. So I said, okay, I adulterated the electrolyte with chlorine, okay, and iodine, whatever is in the city of Dallas water. The TDS runs about 28 on that water anyway. So we had foreign elements in here. So we got in the lab and we started the same experiments but more elaborate. The guy that had the shop brought in a bottle of Body Booster, which is the humanic shale from Utah up there, the 77 colloidal elements, 77 elements in solution, 5 grams per liter is what, right on the bottle. We vacuum distilled it, sure enough, 5 grams per liter. So we put this electrolyte in this cell, half body booster with the 77 colloidal minerals and half distilled water. Started running it. We're making hydrogen. We're making the hydrogen, reburning it, and collecting it in little beakers off of a condenser, a cool condenser. After we ran it for 30 minutes, I was running the cell at 30 amps at 5 volts, overdriving the hell out of it because that's the intention. All of a sudden, the amp meter went bing, pegged. It shorted, the shell shorted. Opened it up. We had about 2 inches of red mud in this cell. So we decanted out everything and took the electrolyte, put it back in, filled it back up with distilled water, took the sludge, went over to the vacuum dryer. We vacuum dried it, put it on a 4 decimal point digital scale, and weighed it out. And we were accumulating dried samples. We ran 13 consecutive runs. Each time, 30 minutes, it would short out 2 inches of mud. And we had 2 PhD chemists from Texas Instruments standing right there watching this. They got on the blackboard and they said, we're going to try explaining this. Here's all this chalk and everything. And then bottom line, when we weighed every piece of that cell, all of the 316L stainless steel plates, we put them on that digital scale, 4 decimal point resolution, weighed everything, added it all up. They got on the blackboard and they added it all up, and the bottom line they came out after they subtracted. We have 30 grams of solid mass here that didn't exist before. Where did it come from? And beats the hell out of me. We made matter out of distilled water and electricity. Anyway, that's the story behind that cell. That's how we got in the elemental. Dr. Bachner's down at Texas A&M down there. I was talking to him. He gave me his lab number in the lab, and I would call him, and I told him all about this. He said, you know, Dr. Bass and I are doing the same thing, but we're doing lateral transmutation in the cold fusion cell, and we're still trying to explain that. And then you come up with creating matter. Anyway, that's all I have. Any questions now? And to answer,
Thank you, Norm Wootan.
to answer your questions, since Dr. Maluski's water's fine for taking care of your hair, but I got tinnitus and everything, and my hearing is not worth a flip, so I'll come up and we'll take your questions, okay, and we'll answer them, whatever questions you have.
We're going to do questions back here with the microphone, so that it gets to everybody. Norm, I just want to say thank you. Your elemental replication and another personal experience led me to actually develop the elemental replicator that was actually on display here a couple of years back. So, and I was actually raised in this field with a lot of your stories from a couple mutual friends of ours. So I just wanted to say thank you for all your inspiration.
Well, thank you.
In the circuit that was locked up, you can't go further with it. You can't.
See, my hearing's bad, but I can't hear you if you don't have that mic right up.
In the circuit, which was locked up.
Yeah, lock rotor. Yeah, lock rotor.
No, the circuit. There was a circuit that went to the patent office, and they
okay.
didn't decline it.
Oh yeah, you're talking about the MRA. Went to the patent office. Yeah.
Yeah, that's the one where you had like a 18% above unity.
Yeah, 18-1 at Georgia Tech. Yeah.
You had the signal generator, and then what's the pre-go? There was like maybe I spelled it wrong. Pre-go. It's
Piezo. The piezo.
Oh, piezo.
It's
Okay.
a piezo. It's a piezo crystal. It's a lead zorconate. The one we used came out of a Branson welders. The Branson welders were used out at Texas Instruments to weld plastics. They were a kinetic impact welder, and you could take plastic sheet and weld it. And they had tons of Branson welders, so we got them. Tanner Electronics in Dallas got in a huge batch, brand new crystals, piezos, and he was advertising them all over the internet. We went up, I bought him out. I bought all of the piezos. I gave them away at the Tesla conference when we brought the MRA up here.
Yeah,
We
I
gave
wanted
them
to
away.
ask which museum, Tesla museum, was that you gave away your product? You said that some of your product, some experiment, you gave to the Tesla museum.
Which subject are we
museum?
talking about? I covered about 5 different, because I can't understand what you're saying.
He was asking, when you gave away your pieces of equipment to the Tesla Museum,
Right.
which Tesla museum did you give them to?
It was in Colorado Springs.
That would be J.W. McGinnis's Tesla
when
Museum?
JW and Steve had the museum at Colorado Springs. I gave them a truckload. There was a ton of stuff I gave them up there.
So that Tesla Museum is still open, but you have to look for it apparently. And it's by invitation, or well, not invitation, but you have to make an appointment to actually go through and get a tour.
Did Dennis Lee leave the stuff in there that he bought?
Dennis Lee took a lot of the stuff, but there is still a lot of equipment there.
'Cause see,
At least
I
there was
saw-
5 years ago.
See, what Dennis Lee did is he was promoting the Sunburst machine. Jerry Decker called me and said, guess what? The big Wimshurst, 26-inch diameter Wimshurst that you gave to the museum, Dennis Lee has it up as his Starburst machine, and that's the one you built and gave to the museum. I said, well, he bought it. He can do whatever he wants with it. And my Adams motor, beautiful Adams motor I did with neodymium magnets and everything, is beautiful. I saw it on the internet here a couple weeks ago. He had it running and all, and featuring that. So, I don't know. He bought the stuff, so do whatever he will with it. Yes, sir.
Yeah, hi. I'm just really curious about the MRI, the 18-to-1 Georgia Tech saw and IBM, and is it possible to manufacture this? You know, I went to the patent office, it's sitting in the drawer, but is it possible, you know, put it in public domain and not exclusive
You're
license?
talking about on the MRA?
Yeah.
The MRA, whenever Power Put Off published 50% of Unity on the MRA, you say the word MRA and they said it doesn't work. Globally, doesn't work. So we just dropped the whole issue. Now, the final affidavit that went to the patent office is well known because the people that were at Denver for the conference up there, New Energy Conference, at the university up there, they tested the Hydrosonic made a MRA that was a mini MRA, very small. We modified it and everything, and we used it for the final patent submission there for, over Unity. The university tested it exactly the way we specified, operating exactly we told them to operate it. 256 times over Unity, and it was signed. That went to the patent office. Now, what happened in the patent office, a month before the patent was to be issued, NSA, called Robert Taylor in Atlanta, and he said, we want a complete file on the MRA. You don't turn down the federal government. Taylor said, fine. So he sends them, they come over and get it. They took the entire file, everything we had done on the MRA, all the testing, everything. So whenever the patent office says at the 11th hour, we're not going to issue the patent and we're not going to give a reason for, we're not going to reject it. We're going to lock it away. The fix was in. Hal Puthoff did the remote viewing program at Stanford University for the CIA. He was CIA. He was Naval Intelligence, NSA. So when NSA requested the file, that killed it at the patent office. They were ordered, lock it away. It was locked away. Simple, plain and simple.
Hi, Norm. I'm wondering, well, so a lot of people say it doesn't work, but why couldn't I buy one or make one?
Say again?
Well, a lot of people would say, oh, it doesn't work, but I don't care. Why couldn't I buy one, make one, use it, and use it for my products?
See, what we did is we created a firestorm, people running around trying to find components to make an MRA that would work. Greg Hydrosonic was a retired engineer from RCA. He lived up in Philadelphia. And Greg saw the thing and everything, and when he saw our project in Fusion Facts, Hal Fox put it in there, and he saw that. And he said, I'm going to build one. So he goes in his hell box. You know, everybody works on electronics has a hell box. You go in there and scratch, and oh, well, here's a little IF transformer, you know, a little ferrite core transformer about that big, like that, 5-to-1 ratio transformer. He said, okay, that's going to be my inductor. And he said, okay, now I don't have a piezo, but I'm going to use something that mimics a piezo perfectly, which is a planar silver mica capacitor, has all of the operating characteristics of a piezo. When you look it up technically, a planar capacitor does that. So he takes this 680 puff planar capacitor with his little ferrite core inductor. He takes his HP 200 just like we had, hooks it all up, and he starts tuning and everything, and he sends us a report. He said, I'm getting 10-to-1 over unity out of this little bitty MRA that I built. And it was published in Fusion Facts and Infinite Energy by Eugene Mello. And Hydrosonic is the one that tested 256 times over unity at Denver. So you can make these things out of almost anything if you understand the principles behind the operation. 99% of the people that even think about an MRA will not go to Turnman, Stanford University. He wrote the Bible on electronics. And chapter 3 delves only on resonant circuits, parallel series resonant circuits. If you read Turnman's work and absorb it, understand it, you can build an MRA and make it work first shot. But you got to go back to Turnman and understand what the Bible says. And he wrote the Bible in electronics. But without that knowledge, you're just, you're up a wet rope, as the country is saying, okay? And most people won't do the research and do the legwork and understand what they're dealing with. They said, oh, I can build one of those, and they go out and start slapping stuff together and said, well, I can't make it work. You might as well have a doorstop.
Thank you for a great talk. In the very beginning, you said you were measuring temperatures at 3,000. What were you using to get the exact temperatures? Because those...
We were optical. We had optical equipment to do that, measuring the temperatures.
Platinum-resistant probes were superior at that time.
Say again?
Platinum resistance probes. The platinum probes were really great for measuring temperature at that time. The platinum resistance probes were great for measuring.
Yeah, we couldn't deal with, we had all kinds of thermocouple stuff. We couldn't operate in that environment and everything. They were doing it with light, measuring it with light and everything. It was optical. The stuff came out of Germany that measured that. Jim Warren out there on the West Coast, they had access to all of that equipment that could read temperatures because they were working with the high temperature refractories that were working up 3,000 or 4,000 degrees, and they had the ability to measure all of that stuff. Yeah, they had labs that had all that out on the West Coast.
And secondly, what were you doing with potassium carbonate in that chamber?
They do what now?
You said you had potassium carbonate in that chamber because
but see, the first cold fusion cells that they worked with used potassium carbonate as the electrolytes.
Right.
You go back to Stanley Pons, their first experiment, they were using potassium carbonate. And everyone else picked up on the same thing and used the same electrolyte. Naturally, I built Mills double nickel because Mills was involved in the cold fusion research. So I just made an octo, put 8 quarters in there and made mine. But it works perfect, makes a lot of hydrogen. It's fun to play with. Then I go down and watch these guys making electrolyzers and all this stuff. We built all kinds of electrolyzers, but I mean, we're not going to be running out there driving our car with just water and anytime soon.
Any other questions? All right. Thank you very much. Norm Wootan.
Thank you very much.
Thank you all for being here, folks.